Hi everyone, in this video we are going to practice converting between the two different common types of units for radiation. So our first two problems in this video have to do with the Curie, the second two problems have to do with the rad. So we're going to start off with a simple one, which is the Curie, and then try to move forward. So for this first question, what we have is how many disintegrations or decays, right, occur per second in 0.1 microcurie of potassium 40. So that's a micro. Go. All right, did you get an answer? This one was a little bit complicated, so if you got a little frustrated or stuck, please just stick with it. We're going to work through it together. The very first thing you need to do is get rid of this micro component. The micro unit is going to throw all of your measurements off, so we need to make sure we get rid of it. So what I'm going to do is start with 0.1 microcuries, and I'm going to get rid of the micro unit. So we know for every 1 times 10 to the 6, so a huge number, basically a million, microcuries, we have 1 curie, okay? So now all we have to do is figure out, or basically remember, that 1 curie is always, this is a constant, equal to 3.7 times 10 to the 10th, and I'm just going to write D per second, so disintegrations per second, because otherwise that word's going to take up too much space. That's it. That's all you had to do for this problem. You need to get rid of the micro, and then you need to convert from curie to disintegrations per second. That's it. So all you had to do is type this into your calculator. If you did it properly, you should end up with something like 3,700 disintegrations per second. All right? If you got stuck there, don't worry. We're going to do another problem that's very similar, but instead of working with potassium 40, we're going to work with carbon 14. So this time, how many disintegrations occur per second for 0.5 microcuries of carbon 14? Go. All right, were you able to do this? Hopefully yes, because we just did something very, very similar in the last problem. Let's work through it together. So we start off with 0.5 microcuries. We have to get rid of that micro component. So 1 times 10 to the 6 microcuries is equal to 1 big curie, basically. Then we need to get out of the curie unit. So 1 curie is equal to 3.7 times 10 to the 10th disintegrations per second. Again, this is something I will always give to you, so please don't feel like you have to memorize that. So if you did this properly, you would end up with something like 18,500 curies per second. Now, if I wanted to be super difficult or challenging, I would have asked you, instead of just solving for a second, I would have asked you to solve for hours, okay? So, or per 1 hour. So let's do that right here together. So now what we just solved for was per second. So now we want to get it into hours. So all we have to do is just a little bit of dimensional analysis. We know in 60 seconds, we have 1 minute, okay? And in 1 hour, we have 60 minutes. And so basically what we can do is just get rid of the second component. Seconds cancel out, minutes cancel out. We're left with hours, and if you do that properly, you end up with something like 6.67 times 10 to the 7th disintegrations per hour. This right here, the last part per hour, that's a classic exam question. That is something that I would expect you to be able to do. So take a second, resolve the problem using it all over again, using the exact same information, and make sure that that's the number you calculate. Now, for those of you who got that, move right on to question 3. Now we're talking about rads. How many rads does an 80 kilogram gorilla receive if they absorb 10 joules of energy? Go. So for this problem, what we have to do is first remember what our conversion is between rad and joules of energy. And so we know that 1 rad is equal to 0.01 joules of energy per every 1 kilogram of tissue. So what we need to do is kind of come up with some kind of ratio so that we can use that conversion right there and get everything to cancel out so that we're left over in rads. And the best way to do that is by inverting these two numbers with our own set of data. So what I mean by that is you would say you have 80 kilograms of species. So in this example, our species is a gorilla. So you have an 80 kilogram gorilla and it received 10 joules of energy. Now what we're going to do is just take this unit and plug it right in here. So we're going, or conversion, I should say. So for every 0.01 joules of energy, we have 1 kilogram of tissue. So our joules cancel out, our kilograms are cancel out, and because we're talking about rads, we can use that unit. If you solve this properly, you should end up with something like 0.08 rads. Easy peasy, right? Now let me do a hard question for you. If a human absorbs 0.5 joules of energy, which is 2 rads, okay, I'm giving you that information, how much does this person weigh? Take your time with this problem. For some reason, this problem right here puts people in this like weird head spin and they can't understand it. So just take your time, write out your units, and slowly and methodically work through this problem. Go. All right, did you get an answer? Hopefully you did. This was the hardest problem though, so please don't get frustrated if you weren't able to master it. But let me show you how I personally approach this problem. I use the exact same math that we just did. So the same thing here where you do kilograms per joules and then use your rad conversion to end up in a number. And so what I would do here is set it up saying we don't know how much this person weighs. We don't know. So I'm just going to say X. We're going to use a variable, X kilograms per 0.5 joules. That number was provided for us in the problem. So X kilograms, that's what we're solving for, divided by 0.5 joules. Now we're just going to use our conversion for rad. So 0.01 joules per every 1 kilogram of tissue. And now we know that this is equal to 2 rads for this example. So 2 rads right here. So now all you have to do, 2 divided by 0.01 times 0.5, and you end up with X being equal to a 100 kilogram person, probably a female, who knows. That's it. This is the hardest problem. Make sure you can do this problem and the rest of them in this video. Have a great week. Take care of yourself. Drink water.